Hello friends and greetings for the day. Welcome back to another tutorial on ISTQB Test Automation Engineer certification. We are in chapter 3 talking about test automation architecture, and today we shall be continuing with the next segment, that is 3.1.4, that is applying different approaches for the test automation test cases. And here we'll be trying to understand what are the different ways by which an automation script can be written when it comes to defining the automation frameworks. Well, when it comes to defining the test cases for the automation test scripts, there are multiple approaches which we can make use of, and certainly adds a lot of value when it comes to the definition of them in different manners. And each one of them have a particular pro and a con related to it, that is the advantage and disadvantages or benefits of it at any point of time. So someone should be really interested to understand that how exactly these different scripting methods can be utilized in what type of scenario, and that would help you to align yourself to that of the need of that scripting method with respect to that of your executions when it comes to a test automation engineer. To start with, of course, we are talking about the first one as capture and playback method. Capture and playback method is pretty simple. Of course, it talks about recording the scripts while interacting with the SUT, and SUT has available components. You just have to turn on the recording and look forward to start performing the activity manually on the product SUT, and automation tool will capture the steps for you, including the information like test data and the architecture of the object on the screen, and makes our job much more easier. In fact, this particular method is being seen as a no code test automation because the tester doesn't really have to be strong with their programming skills in order to prepare the script, and helps them to reduce their effort on concluding with having a test script handy, ready for execution without putting much of the efforts, because the tool is taking care of capturing the entire scripts as they perform while recording this, and this script is so ready to be executable as and when you stop the recording. But at the same time, we would like to understand what are the pros and cons related to this method. The pros certainly are well understood, initially easy to set up and use, but on the other side, when we talk about the cons, the SUT needs to be available while capturing a test case. Don't forget that we are recording the script, and we are recording the script from the SUT. So if SUT is not yet ready, we have to wait. Only feasible for a small scope and a SUT that rarely changes, because if the application changes quite often, then certainly it would become a challenge to maintain this. The cost of maintenance of the script would be high. We may have to re-record it, or we may have to keep updating the script now and then. Also, the captured SUT execution depends highly on the SUT version from which the capture has been taken, because if there was modifications done, the objects might have relocated with their coordinates, or identification may vary as well. So your recorded script can sometimes be good for nothing if the versions are changing and frequently being updated, which goes back to the previous point itself. And one last point to talk about is recording each individual test case instead of reusing existing building blocks is time consuming, because you will have to write them, kind of like record them for every single use case, because separating them would be very difficult, and that would be manual effort. Rather, you will have to record each scenario independently, one after the other, which could again be seen as one of the cons. But however, if I see on the other side, if someone who is new to automation testing, this option would be very, very feasible and easy and cheap option to start with the automation testing. But again, you may not get these features in the open sources. You would need a commercial tool, so there would be a cost and license cost involved to start rolling out such features. So it's not that what looks so great is always easy to adapt. Sometimes there are some hidden costs which the manager should always take into account before concluding on that. The next one we have for you is, of course, the linear scripting method, where linear scripting method is a programming activity and that does not require custom test libraries made by the test automation engineer and used for writing and executing the test scripts. Here, an test automation engineer can leverage any test script that are recorded by a capture playback tool, which then can be modified. Initially easy to set up and use, but as we took from the previous thing, right? So in simple words, all we are trying to say that in the capture and playback, you got some hard-coded scripts which you recorded. But in linear, you're using that same recorded script to modify it to do something else. For example, I recorded a script to log in using the capture and playback, but it hard-coded the data. Now I can copy paste this particular script to do linear programming, which means that I'm going to modify this to perform a data-driven test with help of multiple set of data. Right now, what is data-driven test? We'll be talking in a while, so stay tuned. And data-driven test will be like replacing the hard-coded values of the input of username and password with that of a data sheet, and I can pass multiple iterations to utilize them. So that's pretty much what we talk about. The pros and cons related to this are, of course, pros is easy to set up and start writing the test script because you have the base script available already. And second is, of course, compared to capture and playback, the test scripts can be modified more easily because you will have the freedom to have the flexibility to do that particular job. But again, not ignoring the cons. The cons are hard to maintain, scale, and evolve because it would require a core programming competencies to do that, and each single change has to be maintained. The SUT needs to be available while capturing a test case because that's the fundamental foundation to do this particular one. Only feasible for small scope and SUT that rarely changes. And compared to capture and playback, some programming knowledge is necessary. So yeah, see, we need to just compare the benefits and the drawbacks of each of these methods and try to adapt it, that what exactly would be the best applicable scenarios where we can make use of it. Now, if you think you need to start with a basic recording script so that you can have the base script with you, and then you can do some minimum changes, is what I call it as linear scripting, which would still give me what I'm interested in, but at the same time, I did not invest a lot of time, uh, you know, writing the script from the scratch. So I got the base script, I just modified it, start using it. So it is certainly going to save a lot of time. But at the same time, the someone who is doing this should have good programming knowledge as well. Whereas in capture and playback, it was more of hard coded, but no programming skills was required. The next one we have here is to discuss on the structured scripting method. Here the test libraries are introduced with reusable elements, the test steps and or the user journeys. Programming knowledge is necessary for the creation and maintenance of the test script in this approach. So we can correlate this to our previous tutorial. In our previous tutorial, we discussed that what exactly libraries are. They are independent test cases which we use for executions, and we write it right from the scratch. So here there's no support for capture and playback. In fact, the libraries can be written independently in a notepad also, which can be later saved as an executable file and can be associated with a test automation tool. But here, the only challenge which we see is it is completely dependent on the programming language. So there will be no support, no autocomplete options, and all those sort of things. So you will have to start writing right from the scratch. And someone who is expert in drafting this scripts should be, utilized as a test automation engineer. When we talk about the pros and cons, of course, the pros are easy to maintain, scale, port, adapt, and evolve because they are open libraries, whereas business logic can be separated from the test script as well. Whereas on the other side, the cons are programming knowledge is mandatory, and initial investment into task development and defining the testware is time consuming because we don't have any foundation script with us. We will have to set up everything on our own right from the scratch. And that's what makes a little bit time consuming. In turn, the investment of the cost is also high. Let's move on to the next one. The next we have, of course, is to discuss on the test-driven development. The test-driven development is a very simple approach. If you remember from your foundation, we discussed on that generally first the code will be written and then we write the script. So it's a very common and ordinary approach of doing the test-driven development. But when it comes to the TDD, it's other way around, right? You write the test case first and then give it to the developers. The developers write the test code in order to make them pass. And if you see the explanation here, it clearly says that initially you will run the test without any code. So of course it will be a failure that is represented as red. And then the developer writes the code to make that test pass. And when the test case passes, it's a green, and that's where the code is ready. Then it can be refactored to optimize it, and then able to abide by the clean coding principles, and that's where it basically becomes well ready to be executable or considered. to be more of like the code is ready for the validation. So it's more of like other way around, that instead of writing the code first, you're writing the test first. But again, it's again a different automation approach altogether. The way the TDD tests are written are different from the conventional methods, so we must understand the differences between them, right? Mostly TDD is used for unit testing, and we write simple small test, not so complicated system tests. If I talk about the pros and cons related to TDD, the pros are simplifies component test level development, the improves code quality and the structure of the code, improves testability, makes it easier to achieve a desirable code coverage because the tests are written first and then the code is written. So of course my code would certainly fulfill all the things in the test, and thus I have desirable code coverage achieved by default, right? Also, reduces the defect propagation to higher test levels because it's other way around. We are writing the code to fulfill the test. Improves communication between developer, business representative, and testers, and also user stories that are not verified using GUI testing and API testing can quickly achieve exit criteria by following TDD. Why? Because of course these information are going to require a lot of understanding, but the GUI and API is not something what we prefer to use for unit testing. In unit testing, we use white box test techniques, so that means we are working at the code level. So TDD is more recommended for component level, thus we do not worry about GUI and APIs, and simple components can be tested very well. And that's where we also say that the component level tests are very concrete, and we spend more time when it comes to agile. And for that agile perspective, we had one point here which said that we can improve the communication between the three stakeholders: developers, testers, and business representative, by using TDD. On the other hand, the cons include programming knowledge is mandatory, and initial investment into the TAF is time consuming, which remains the same because now everything is dependent on the way you write it. Let's move on to the next one. The next one we have for you is, of course, the data-driven development. Data-driven development is pretty simple when you want to use a script for multiple set of data. So single set of instruction is being reused for multiple set of data. So instead of writing it multiple times, you are writing the script only once, but instead of hard coding the data at the end, you are using a parameter, which is a variable, which will be equated to a data source. The data source can be inbuilt within the tool, or can be an Excel sheet outside, can be another notepad file, and you can just automate it. And you can run the script for multiple iterations with unique set of data or different set of data for n number of iterations. Of course, that's very simple. So let's go to the pros and cons. The pros talks about allows quick and easy test case expansion through the data feeds. The cost of adding new automated tests can be significantly reduced because now we don't have to copy paste script multiple times to run with different set of data. I can use the single set of instruction to run it with multiple set of data. The analysis can specify automated tests by populating one or more test data files that describe the test, and this gives test analysis more freedom to specify automated tests with less dependency on the technical test analysis. Whereas on the cons, of course, we have proper test data management may be necessary. So, of course, data-driven testing is mainly being referred from the data point of view. So, as far as you have a test to be executed multiple times with different data, this framework or this scripting method could be of great help. The next one we have is to discuss on the keyword-driven framework. And again, keyword-driven development or framework is a way of writing tests where we want to use keywords in order to perform the required hand-picked test cases. So of course, the base remains on the data-driven testing. That is the script which can be executed for multiple set of data. But here it is more of like modular way of scripting. Like we discussed on the keyword example in our previous tutorial, that you may create core libraries with multiple specific keywords and then call only those keywords which you want to run. So instead of using an iterator to hit every single test and check that this is the one which is to be executed, I can directly call the keywords which I want to run. In this, again, the keyword and the data is very important because we need to run a test with multiple set of data as well. So keyword will call that particular function script, and data will supply the data to that script in order to run that. So keyword driven is again simple and enough or important for regression testing, because generally when we do regression testing based on any change, the change may not really invite us to run all the test cases in the regression test suite. So there could be some limited things which we want to run, and keyword driven testing could be of great help. The pros and cons related to this are, of course, the pros are the test analyst and business analyst can be involved in the creation of automated test cases by following the keyword driven testing approach. Keyword driven testing can also be used for manual testing independent of test automation. The reason is that because the keywords are so designed that it is easy for someone to understand without worrying about what's the underlying code. So all we have to do as a manual tester is to write call so and so, call launch, call login, call logout. But I don't really care what's written inside launch. So an automation team can build the script for you, and you can go ahead as a manual tester to execute it. So that's another benefit what we have of keyword driven testing. Whereas the challenges are certainly because we are making it more complex, related to implementing and maintaining keyword is a complex task that TAs need to cover, which can become challenging when the scope grows, and it also creates a huge effort for smaller systems. So we generally do not tend to create a bigger framework like this when we have small systems. We generally prefer to use them for bigger systems because the ROI, that is return on investment, is calculated on that basis. Because for a smaller, if I spend more than the amount of testing which we can do without automation, is something which you need to worry about, right? For small applications, if I invest high amount of thing for automation, I don't see any benefits in return. But for a bigger application, I need a solution, and I'm ready to invest that amount, which can return me a lot of benefits on this investment. One last thing to talk about is, of course, the behavior-driven development. And behavior-driven development is again well understood from our other discussions that here the test cases are derived from the specifications, that is user stories. But the different way of writing it or the pattern is the given, when, then. We call this language as Gherkin, and this particular language is a natural language format. And again, of course, it's not that the keywords are getting executed. The given represents prerequisite, when represents the set of actions, and then represents the expected outcome. And under each of these keywords, we will be writing some simple natural English. And behind the screen, you would have libraries or scripts which will be called from these keywords. So it's certainly not that the English language is getting executed. English language is more of like a keyword which is referring to a script, but performing in a sequential action like given, the prerequisites are fulfilled. When a user performs these steps, then this is what should happen. So that's the point. So yes, behavior-driven development is another way of leveraging the automation in a better way for people who are not so well versed with the automation skills or programming skills. But to build that, of course, you would need programming language. So pros here include improves communication between developer, representative, and testers. This point simply means one thing, that it requires collaboration from all the three, and as they collaborate, it helps you to improve communication among them. Point number two, of course, automated BDD scenarios acts as test cases and ensures coverage of specification. BDD can be leveraged in producing multiple test types on different levels of test parameter. That means, unlike TDD, which is limited to component testing, BDD testing or BDD framework can help us to deal with further levels as well, like integration, system, and acceptance too. When I talk about the cons of this, the cons are additional test cases, typically negative conditions, and edge cases still need to be defined by the team, typically by a test analyst or a test automation engineer. Many teams confuse BDD to be only a way of writing test case in natural language and do not involve the business representative and developers in a whole approach. So as you see, the pros was telling us that it's a collaborative approach. So other way around, if you don't involve them, that's a negative side of it. The next point is, of course, implementing and maintaining the natural language test steps is a complex task for the TAEs to cover, and overly complex test steps will turn debugging into difficult and costly activity. So one important thing is that when we talk about the natural languages, of course, we use generic English keywords to define that what a user is trying to do. So test automation engineers may not be so familiar with the business logic and may find it difficult to define them. So that's where the business representative needs to collaborate with the automation testers to help them to do that, and we can overcome that. And the last one, of course, is certainly to talk about the debugging, which is pretty much important. The more complexity you deal with, the more the challenges are. So we don't need to tell you that the bigger and complex you build the task, the challenging it would be. So that's all the methods what we can make use of when it comes to the scripting type when it builds an automation framework. However, I know this tutorial became a little longer, but yet I just wanted to cover it in one go so that you can keep correlating them as you learn them together. So that's all from this particular tutorial, team. Should you have anything else, feel free to comment below. I'm always there to address your queries and answer them well. Till then, keep learning, keep exploring, keep understanding the context. Thanks for watching the video, team, and happy learning.